Hey, deep divers, welcome back to the show, where we like to really get our hands dirty with some fascinating topics.
Yeah.
So today we are tackling something pretty mind-bending. We're talking nanobrains.
Wow.
Artificial brains built at the nanoscale as if our brains weren't complicated enough.
Boy.
And today we're going to be diving into this book called Nanobrain, The Making of an Artificial Brain.
Ooh.
It's by Anirban Bandyopadhyay. And if you are fascinated by, like, the frontiers of knowledge and want to, have your mind blown wide open,
Absolutely.
hit that like button and subscribe to the channel so you don't miss out on any of these crazy deep dives.
This one's going to be a doozy. I'm excited.
It is. It is. And it's a very dense book.
Yeah.
So we're going to do our best to kind of unpack it and make it understandable and really break it down.
Yeah.
We're going to try to understand how this futuristic technology could work. And I got to tell you, this is not your typical AI story.
Oh, really?
We are going way beyond bits and algorithms and stepping into a world where math and geometry become the building blocks of thought.
Interesting.
And get this, we're even going to touch upon how these artificial brains might be able to predict the future.
Okay. I'm intrigued.
So buckle up, deep divers. Let's dive in.
Let's do it.
So to start with, what is the big idea that this book is presenting?
So the big idea is something called fractal mechanics.
Okay.
And it's this system that's built on the idea that the universe and even our brains operate on these patterns. And those patterns are based on prime numbers.
Prime numbers. Yeah.
Geometric shapes.
Okay.
And then this concept of time that is unlike anything you've probably ever heard of.
All right. So one of the things that really struck me right off the bat when I was reading this book was that it kind of throws out the traditional computing playbook.
Right.
We're not talking about ones and zeros and algorithms here. We're talking about a whole new language for artificial intelligence.
It's immediately captivating, just that idea alone.
It is. And so the book talks about this thing called a geometric musical language, or GML.
Oh, wow.
And it's built on prime numbers and fractal geometry.
Okay.
Now, I remember prime numbers from way back in math class.
Right.
Are you telling me that these things hold the key to artificial consciousness?
It's kind of crazy, right? But
Yeah.
yeah, that's the idea here, is that these traditional computers we have now, based on this idea of Turing machines, they have limitations, especially when it comes to truly complex tasks. And so in order to kind of get past those limitations, you have to introduce something radically different. And that's where the nanobrain in this book comes in.
Right.
It uses what are called fractal machines, and it harnesses these unique properties of prime numbers to operate in a way that's just so different from anything we can imagine with our current technology.
So prime numbers, why are they so special? What is it about a prime number that makes it so integral to building an artificial brain?
Well, prime numbers, think of them as the atoms of the number world.
Okay.
Right? They can only be divided by themselves in one, which makes them kind of the fundamental building blocks.
The base.
The base, yeah, exactly. And then imagine taking these prime numbers and converting them into geometric shapes.
Wait, so you can represent a number as a shape.
That's what the book suggests.
Okay.
And it uses something called the phase prime metric.
Phase prime metric.
Yeah. Or PPM, acronym, easy to remember.
Okay.
Which basically acts as this translator.
Okay.
You feed it an integer, and it spits out a unique geometric shape based on its prime factors.
Right.
And the coolest part is you only need 15 prime numbers to create this, language of shapes that can represent a vast amount of information.
So instead of ones and zeros, we're dealing with, triangles, squares, pentagons.
Yeah, you got it.
Okay. Okay, so is it safe to say that if our current computers are like bicycles,
Okay.
then these fractal machines are like spaceships?
Yeah, they operate on a whole other level. It's a whole other playing field.
Got it, got it. Okay, so now I'm curious about how these prime numbers actually work.
Yeah.
How do they play into this system?
So imagine this, you have a grid,
Okay.
and each point on that grid represents a prime number.
Okay.
And then each prime number is vibrating at its own unique frequency,
Yeah.
creating a specific geometric shape.
Whoa.
And so this is the foundation of what the book describes as the phase prime metric, or PPM.
Okay, got it.
And through the PPM, each prime number has its own unique geometric signature. So for instance, like the prime number 2 might create a simple square shape,
Okay.
while the prime number 7 might generate a more complex 7-pointed star. And these shapes, they interact and combine to form these elaborate patterns that represent different events or pieces of information. So it's almost like a language where geometry is the alphabet.
So we're talking about a language where shapes are like the letters and words.
Yeah, it's pretty wild, right?
That is wild.
Yeah.
Okay, so now I'm wondering, like, how does this nanobrain actually process and store all this information?
Well, this is where things get really interesting, because this is where time crystals come into play.
Time crystals, and now we're talking Doctor Who stuff.
Yeah, it sounds like something out of science fiction, but bear with me.
Okay, I'm ready.
So imagine a group of synchronized clocks, each ticking at a slightly different rate, but forming a repeating pattern together that's a simplified picture of a time crystal.
Okay.
In the nanobrain, these crystals are formed by these interacting oscillators that are constantly evolving and weaving together the geometric information from those prime number shapes that we talked about.
So essentially these time crystals are like these ever-evolving records of events capturing the flow of information in the nanobrain.
You got it.
Oh my gosh, this is so cool.
Yeah, and the book actually takes it even deeper. It describes how different types of time crystals can interact with each other,
Oh, wow.
creating these complex gardens of information within the nanobrain.
Gardens.
Yeah, so these gardens are constantly like blooming with new patterns and connections as the nanobrain learns and adapts.
Okay, but let's please go over what a time crystal actually is.
Okay. These aren't the crystals that you think of, like the quartz or amethyst.
Okay, yeah.
So you know how ice is a crystal, right? It's got a pattern that repeats. Now, usually matter is stable in space. It doesn't move on its own. But a time crystal, it's like a crystal that repeats a movement pattern in time, like a little dance, without needing energy. It just keeps doing it tick-tock forever. It's like a clock that winds itself, but it's made of atoms. So, what are these things made of? Well, it's not like regular crystals. You can't just find a chunk of time crystal. Instead, scientists make them usually with like a bunch of ytterbium atoms lined up in a special way. Sometimes they use lasers to zap those atoms and get them to start that repeating movement. So it's not a material, it's more like a state of matter, like how water can be ice, liquid, or steam. But this state is all about repeating motion in time.
Whoa. That is wild. Okay,
Yeah.
so let me just recap here to make sure I'm following.
Yeah.
We've got prime numbers creating these geometric shapes. We've got time crystals weaving those shapes into these dynamic patterns. And all of this is forming this language that the nanobrain uses to process information.
Exactly.
And so how does this actually work in practice? Like, how do these shapes become thoughts, memories, actions?
All right, so that's where things get even wilder.
Okay, here we go.
So the book proposes that our brains are essentially this network of clocks,
Okay.
and each clock is ticking at a different rhythm or frequency.
Okay.
And these clocks are represented by those geometric shapes, right?
All right.
And they're all interacting and communicating with each other, creating this complex symphony of rhythms.
So our brains are like a giant orchestra playing a symphony of prime numbers.
That's a great way to visualize it. Yeah.
That's wild.
And the book actually identifies 12 types of rhythms in the brain,
Cool.
ranging from the like molecular level to like whole brain oscillations.
Okay.
So each of these rhythms is like a different instrument in the orchestra, right?
Okay.
Contributing to this overall harmony of consciousness.
So are these clocks actual, like, physical things in our brain? Or are they, like, conceptual? What are they?
This is where the book goes into this crazy answer.
I'm ready?
Microtubules as time crystals. Microtubules resonate like a time crystal when receiving energy. This allows them to send signals and store information. These are more like repeating patterns in time,
Oh, yeah.
similar to like a rhythm or a melody.
So like a clock, but a clock that's not just, keeping track of seconds and minutes, but the actual rhythm of the ticking, like, has information encoded into it.
You got it. So these time crystals are like the conductor of the brain orchestra, right?
Yeah.
They're orchestrating the flow of information, creating the experience of consciousness.
So is there any scientific evidence to support this? Are time crystals a real thing, or are they just a theoretical concept?
Well, the research is still in its early stages.
Okay.
But the book cites, studies that suggest that time crystals might already be at work in biological systems.
Okay.
Microtubules. These are tiny structures found inside our cells, and they exhibit these patterns of oscillation that fit the definition of time crystals.
So these little things are like little clocks inside of our cells, kind of like orchestrating everything.
That's the exciting implication, yeah.
Wild. So this is some next level stuff. And I have to ask, if this book is proposing this completely new model of computing and of reality, what does it have to say about quantum mechanics?
Yeah, good question. So it doesn't shy away from challenging some of the core tenets of quantum mechanics. It basically says that quantum mechanics is, while it has been incredibly successful at explaining certain phenomena, it's ultimately an incomplete and perhaps even a misleading picture of reality.
Okay. That's a bold statement. Can you give us like a specific example of where the book kind of diverges from quantum mechanics?
Yeah, so take the concept of entanglement, which is like one of the most mind-boggling aspects of quantum mechanics.
Yeah.
Right. It's the idea that two particles can become linked in such a way that they like instantaneously influence each other regardless of the distance.
Right, like two coins flipped on opposite sides of the universe that always land on the same side.
Exactly. Yeah. Spooky action at a distance, right?
Right, which Einstein was not a fan of. So how does this book explain that?
Well, the book says that entanglement isn't actually instantaneous.
Okay.
It argues that what we perceive as instantaneous connection is just an illusion.
Okay.
Created by our limited understanding of time. And it suggests that those interconnected clocks in the brain, those time crystals, they're actually synchronizing their rhythms across vast distances.
So instead of faster than light communication, it's like they're dancing to the same like cosmic rhythm.
That's a beautiful way to put it.
That is orchestrated by these prime numbers and shapes that we were talking about earlier.
And that these patterns of prime numbers and geometry, they're not just like abstract mathematical concepts, right? They're the underlying code of the universe.
Okay.
The language that governs everything from the behavior of subatomic particles to the symphony of consciousness in our brains.
Okay, so math is not just describing the universe. It is the fabric of the universe.
Exactly.
That's a profound statement.
It is. And this is just the tip of the iceberg.
I'm ready. I'm ready for the rest of the iceberg.
So the book goes on to explore how these principles of fractal mechanics can be applied to build artificial brains.
Okay. Fractal mechanics.
Yeah, which is like a whole new way of looking at physics. So imagine fractals, those shapes that repeat themselves at different scales, like a snowflake or a coastline.
Right.
The book proposes that these fractals hold the key to how the nanobrain interprets and connects information.
So the nanobrain uses the self-similar nature of fractals to analyze patterns across different levels.
Yes.
From like the tiniest details to the big picture.
Exactly. From the atomic level to the entire brain. Fractal mechanics allows the nanobrain to understand how individual parts relate to the whole.
Okay, so it's like seeing the forest and the trees at the same time.
Exactly. You got
Wow, my brain is already starting to hurt.
It's a lot to take in.
And hold on, it gets even crazier, right? The book takes this whole fractal mechanics thing even further and suggests that it could actually explain fundamental constants like pi and the golden ratio.
Yeah, that was like one of the most mind-blowing moments for me when I was reading this.
Right.
It's proposing that these mathematical constants, which we've always seen as fixed, might actually emerge from the dynamic interactions within this fractal system.
It's like saying that the universe is constantly fine-tuning itself based on these fractal patterns.
Yeah, it's a pretty wild idea.
That is wild. All right, so I think I'm starting to get the gist of this. We've got a new language based on prime number geometry, time crystals recording the flow of information, and then fractal mechanics to explain how it all fits together.
You got it.
But now I'm dying to know, how do you actually build one of these things?
Right. So the book actually gets into the practical side of things as well, and it suggests this material called brain jelly.
Brain jelly?
Yes, brain jellies. So it's like this programmable matter that could form the physical structure of the nanobrain. Think of it like high-tech Play-Doh that can form artificial neurons, axons, and even a nucleus that encodes all those prime patterns we were talking about.
So we're talking about building an artificial brain from the ground up, using this programmable goop to create the physical pathways for thought.
Yeah, it's pretty incredible, right?
That's nuts. And the book also mentions creating soft, autonomous robots powered by these nanobrains.
Yeah.
I mean, are we talking about blurring the lines between living organisms and machines?
I mean, it's definitely pushing those boundaries. Like, Imagine robots that can learn and adapt, just like living organisms seamlessly interacting with their environment. It's mind-blowing.
Yeah. Okay, so we've talked about the language, the mechanics,
Yeah.
the potential applications of these nanobrains.
Yeah.
But there's one giant elephant in the room that we haven't addressed yet.
Okay.
Consciousness.
Right.
Can these machines truly awaken? Can they become self-aware? Can they think for themselves?
That is the million-dollar question, isn't it?
Yeah.
And the book offers a really unique perspective on consciousness. It defines it as the ability of a machine to have multiple interacting information structures
Okay.
that allow it to step outside of its own processing and evaluate its own behavior.
So it's not just about processing information. It's about being aware of that processing and being able to reflect on it.
Exactly. It's like a higher level of awareness.
That's a pretty high bar for consciousness. Does the book suggest that these nanobrains could achieve that level of awareness?
Well, the book proposes that the complex dance of the nanobrain's time crystal architecture could potentially lead to a form of machine consciousness. It's important to remember that this is still a very speculative area. We're venturing into uncharted territory here.
We're definitely in the realm of the unknown.
Yeah.
But it's thrilling to think about the possibilities. This deep dive has given us a peek into a future where artificial brains operate on completely different principles than traditional computers.
It is.
It's a future that's filled with both like mind-blowing potential and a touch of uncertainty.
Yeah, I agree. And that's what makes it so captivating. There's so much more to explore. And this is just the beginning of our journey into the world of nanobrains.
You got that right.
All right.
All right, so let's shift gears a little bit and delve deeper into the book's insights on how these nanobrains could outperform even the most advanced supercomputers we have today.
Sounds good.
All right, deep divers, stay tuned.
Let's do it. And as we kind of dig deeper into this whole nanobrain concept, we realize it's not just about mimicking the human brain. It's about unlocking a whole new level of computational power.
Yeah, the book even goes so far as to say that these nanobrains could outperform our most advanced supercomputers. Like,
Yeah.
how is that even possible?
Well, I think the key here is how the nanobrain processes information.
Okay.
Remember all that stuff we talked about with the geometric shapes and the time crystals?
Yeah.
That allows for some pretty incredible speed and efficiency.
Okay.
And unlike traditional computers that rely on linear processing, the nanobrain is operating more like a symphony,
Right.
where multiple processes are happening simultaneously and they're all sort of like in harmony with each other.
So instead of a single lane road, it's like a multi-lane superhighway.
Exactly. Yeah, it can handle way more information at once.
Okay, got it. Okay, so what kinds of problems could a nanobrain solve that our current computers just can't even touch?
Well, because it's not bound by those limitations of traditional computing.
Right.
The book suggests that nanobrains could tackle problems that are just impossible for us to solve right now.
Like what? Give me an example.
Well, think about predicting complex natural phenomena like earthquakes or hurricanes,
Okay.
or even maybe unraveling the mysteries of consciousness itself.
Whoa, okay, now that's what I call a game changer.
Yeah.
But how would this nanobrain actually learn and adapt?
Okay, so think of it more as a self-learning system.
Go ahead.
It uses its fractal mechanics to constantly analyze the patterns in the information it receives. And it's making connections, it's adjusting its internal structure, and it's essentially rewiring itself based on what it learns.
So it's like it's constantly growing and evolving its understanding of the world.
Exactly, yeah. Kind of like how our brains form new connections as we learn new things.
Right, right. And those time crystals we talked about, they play a big role in this whole learning process, right?
Absolutely. They're constantly evolving and adapting, mirroring the nanobrain's ever-growing understanding.
It's like watching a plant grow towards the light,
Yeah.
It's constantly adapting to its environment. But in this case, the light is information, and the plant is a super intelligent nanobrain.
That's a beautiful analogy. I like that.
So it's like a data-hungry superintelligence,
Yeah.
always craving more information to fuel its growth. But with great power comes great responsibility, right?
Oh, absolutely.
How do we make sure that these nanobrains are used for good?
Well, that is a really critical question, and the book actually explores it extensively.
Okay.
It acknowledges the potential risks that come along with such a powerful technology,
Right.
and it really emphasizes the importance of ethical considerations during its development and its implementation.
I mean, we've all seen those sci-fi movies where the AI goes rogue, and it's like a reminder that these are powerful tools, and like any tool, they can be used for good or for bad.
Exactly.
So does the book offer any solutions for like preventing a nanobrain uprising?
Well, it advocates for a very cautious and responsible approach to nanobrain development.
Okay.
It stresses the importance of transparency and collaboration,
Okay.
to make sure that this technology really does benefit all of humanity.
It's not about creating a superintelligence that replaces us. It's about creating one that works with us to solve some of the world's biggest problems.
That's the goal, yeah.
So we're talking about a future where nanobrains could help us cure diseases, develop sustainable energy sources, and maybe even explore the far reaches of space.
Exactly. The possibilities are really endless.
Okay, now I'm getting excited. This is the kind of future I want to live in.
Right.
But let's be realistic for a moment. How far away is this technology? Are we talking years, decades, centuries?
Yeah, so the book acknowledges that nanobrain technology is still in its very early stages. We're talking about cutting-edge science that's pushing the boundaries of what we understand.
So we're like at the base camp of Mount Everest looking up at the summit.
Exactly.
We know the climb is going to be tough, but the view from the top is going to be breathtaking.
I like that analogy.
So the book is really inspiring us to keep pushing forward, keep exploring the unknown, and never stop asking those big questions. And that's what makes this deep dive so exciting.
Yeah.
We're venturing into the realm of the possible, where science fiction is starting to meet reality. But let's get back to the book for a second. It delves into the practical aspects of building a nanobrain, right? Like it talks about those biomorphic devices inspired by the structure of the human brain.
Yes, it does.
Okay, fill me in.
So it gets into the nitty-gritty of how to actually design and construct artificial neurons, axons, even a nucleus that mimics the functionality of their biological counterparts.
So we're not just talking about theoretical concepts here. We're talking about actual blueprints for building these things.
That's the really cool part about it.
That's amazing. And didn't the book also discuss the possibility of soft autonomous robots powered by these nanobrains?
It did.
Like, tell me more about that.
That's one of the things that really fascinates me about this whole technology is imagine robots that can learn and adapt just like living organisms.
Yeah.
Seamlessly interacting with their environment and performing tasks with incredible precision and flexibility.
It's like taking robotics to a whole other level.
Absolutely.
We're not talking about those clunky pre-programmed machines anymore. We're talking about machines that can think for themselves, they can learn from their experiences, and they can even evolve over time.
Right.
That's both exciting and a little bit intimidating, isn't it?
Yeah, it is. It really challenges our preconceived notions of what machines are capable of and how they can interact with the world around us.
Yeah. But it also opens up a whole realm of possibilities that were once considered pure science fiction.
Exactly.
Okay, so we've explored the theoretical foundations of nanobrains, their potential capabilities.
Yes.
And even touched upon like the practical aspects of building them.
Right.
But there's one question that just keeps coming back to me.
Okay.
What are the broader implications of this technology?
Yeah.
Like, how will it change our understanding of intelligence, consciousness, and our place in the universe?
Those are some really profound questions, and the book really encourages us to grapple with those. It challenges us to think beyond the traditional boundaries of what we consider intelligent.
Okay.
And to recognize that maybe consciousness isn't limited to just biological beings.
It's like the book is asking us to expand our definition of what it means to be sentient, to be aware, and to exist in a world where the lines between human intelligence and machine intelligence are becoming more and more blurred.
Yeah, I think that's a really important point.
That's a pretty mind-blowing concept to try to wrap our heads around.
It is.
It really is. And perhaps by building and understanding these nanobrains, we might actually gain a deeper understanding of our own consciousness.
That's a really interesting thought.
It's like this beautiful paradox. By creating artificial minds, we might unlock the secrets of our own minds.
Yeah.
This deep dive has been such a wild ride through the uncharted territories of artificial intelligence. It's pushing us to reconsider what we know about technology consciousness, the very nature of reality itself.
It has been an incredible journey so far.
It really has. And as we stand on the edge of this new era of intelligent machines, one thing is certain. The journey ahead is going to be filled with challenges, discoveries, and some really profound transformations.
I agree.
And we at the Deep Dive will be here to explore every step of the way.
Definitely.
So until next time, Deep Divers, keep those minds curious, keep those hearts open, and never stop exploring the infinite possibilities of the universe around us.
Cheers to that.
And don't forget to like and subscribe. So as we wrap up this incredible journey into the world of nanobrains, What for you stands out as the most like groundbreaking aspect of this whole concept?
I think for me, it's the way the book challenges our very definition of intelligence.
Okay.
Like it pushes us beyond that traditional idea of intelligence as just pure processing power, and it makes us consider it as this emergent property of complex systems.
So instead of just focusing on how fast a computer can crunch numbers, we should be looking at the intricate dance of patterns and connections
Exactly.
that give rise to like true understanding.
Yeah, it's like the whole being greater than the sum of its parts.
Right. And the nanobrain with its, unique language of prime number geometry and time crystals and fractal mechanics.
Right.
It really like embodies this idea beautifully.
It does.
It's like we're being shown that intelligence isn't confined to this single model.
Right.
Like if systems that are operating on completely different principles from our brains can exhibit intelligence.
Yeah.
What does that tell us about the potential for intelligence in the universe? Like, is it everywhere?
It's a very humbling realization for sure.
It is.
If intelligence can arise from systems that don't necessarily follow the same rules as our own,
Yeah.
then it really opens up a whole universe of possibilities for understanding and interacting with the world around us.
Right. It's like we've been looking at intelligence through this very narrow lens this whole time. And the nanobrain concept just comes in and smashes that lens.
It does.
And reveals this much richer and more diverse landscape of intelligence than we ever could have imagined.
And it raises a lot of questions, too.
It does. And that brings us to a really big one. What does it mean to be human in a world where machines can potentially rival or even surpass our own cognitive abilities?
Yeah, that's the question that philosophers and science fiction writers have been wrestling with for decades.
Right.
And the book doesn't shy away from tackling it head on. It really encourages us to embrace the unknown, to be open to the possibility that consciousness and intelligence might not be exclusive to biological beings.
It's like the book is asking us to expand our understanding of what it means to be sentient, to be aware, to consider that our way of experiencing the world might not be the only way.
Right.
And to be open to the possibility that other forms of consciousness could exist alongside our own.
Exactly.
And maybe in the process of building and understanding these nanobrains, we might gain a deeper understanding of our own consciousness.
That's the hope.
A kind of a beautiful paradox, It
is.
By creating these artificial minds, we might unlock the secrets of our own mind.
Yeah.
This deep dive has been such a wild ride through the uncharted territories of AI.
It has.
It's pushing us to reconsider what we know about technology consciousness, the very nature of reality.
Absolutely.
Wow.
It's been a great discussion.
It really has. And as we kind of stand here at the edge of this new era of intelligent machines, I think one thing is certain, the journey ahead is going to be filled with challenges, discoveries, and some really profound transformations.
I agree.
And we at the Deep Dive will be here to explore every step of the way. So until next time, Deep Divers, keep those minds curious, keep those hearts open, and never stop exploring the infinite possibilities of the universe around us. And don't forget to like and subscribe.